Recent years, we've all been dealing with something invisible. You ask it questions, it writes articles and code, it chats with you. We call it GPT, or large language models. But most people still wonder, it's smart, it seems human. Will it take over one day? This video isn't about consciousness. We're doing one thing, breaking down the engineering. From the moment you type to you get a reply. What happens in those servers? For humans, language is about emotion and logic. For GPT, language is shredded numbers. You type a sentence, it sees small units, which are tokens. A token can be one character, part of a word, even a punctuation mark or space. GPT uses a method called BPE. It scans massive text, finds common character pairs, merges them into bigger units. When GPT runs, it has only one job. Look at the text. Calculate the odds for every possible next token. Then pick one. Think of it as a massive fill-in-the-blank game. The model would look at the previous words. Specifically, it would calculate the probability for every token in its vocabulary. The final output is a probability list. Then it picks one token from that distribution list. Here's a simple analogy. GPT is a super-powered parrot that reads huge amount of human text. You give it first half of a sentence, it doesn't think, but runs statistical reasoning. What do humans usually write next? It's all probability. By guessing the next word, it builds a reply that looks logical. One of GPT's biggest skills is keeping track over long-range context. About what was said earlier, the engineering trick is called self-attention. Imagine a meeting. Every token is a person in the room. When a token like the word he needs to figure out who it refers to, it will initiate 3 steps. Step 1, ask questions. He sends out a query to everyone. Who might be connected to me? Step 2, check everyone's tag. Every other token holds up a key. He scores how well each key matches its query. High score, words like John earlier get more attention. Low score, words like table get ignored. Step 3, pull out valuable information. He takes a weighted average of everyone's content. The result? A new representation of he that now carries information about John. That's self-attention. Every token, when figuring itself out, looks back at every token before it, just with different levels of focus. A transformer model simply stacks dozens of layers of this operation, synthesizing information by calculating weights. So how does GPT write a whole long article? The answer lies in auto-regressive generation. This means the model follows strict time order, generating words token by token. It can't finish the whole sentence instantly, but predict the first token, add it to the original text to form a new text, predict the next token, repeat until it hits the end token. There's a detail that shapes the AI's personality. How do we pick that one token from the list? Several settings control this. Temperature, high temperature spreads out the odds. Low probability words get a chance. Meanwhile, the lower the temperature, the more opposite it is. Greedy search, always pick the token with highest probability score. It's stable, but also boring. Top K means picking one randomly from the top K candidate words. Top P, only pick from group of top candidates whose combined probability reaches P. High temperature plus large top P gives more creative results, but also more risk of going off track. Now you have a basic understanding of GPT's inner world. Every smooth reply is built on expensive silicon. Trillions of floating point operations per second, stacked up. Let's look at 2 of the most famous chips today, the A100 and the H200. More memory means bigger models, and longer input context on a single card. Higher bandwidth means the data transfer and matrix multiplication is faster, and the time required for a single forward pass and backward pass is shorter. But each GPU pulls 300 to 700 watts of power. A large training cluster uses thousands of these cards, running for weeks. That adds up to a very real electricity bill. Logic works, the chips are ready. Everything is set. Next video, we'll break down how large language models are actually born.